Welcome, video example 2, unit 3, chemistry 1B. We're going to be doing some more calculation of cell potentials, and in this case there are two examples under this video example. We want to predict the standard cell potential when magnesium and cadmium are added to their solutions of their respective ions. Given the information that's on the screen, you can see that cadmium 2+ has the least negative value. In other words, the more positive value, it is going to be reduced, while magnesium has the more negative value, and so it is oxidized. Okay, so we can work out the cell potential by saying the E reduction minus E oxidation, and you will see that if we calculate the final value, we get a value of plus 1.97, so we actually have a spontaneous reaction which we can write as the full equation over here. Okay, if we looked at another example, what would be the cell reaction and cell potential for the galvanic cell employing the following half reactions? So we have cobalt 2+ going to cobalt solid and gold 3+ going to gold solid with their respective values. You can see that the gold 3+ is more positive, so it's going to be reduced, while the cobalt is negative, so that's going to be oxidized. Okay, so that's essentially what I've just said. Now, you will notice that the electrons need to balance. So we have 2 electrons here and 3 electrons here. Now, that means we have to multiply the cobalt by 3 and the gold by 2, such that we get 6 electrons in total and 6 electrons in total here, so that they cancel out. Okay, so they're on opposite sides of the equation, so they're going to cancel out with one another. All right, so our final reaction shows the reaction over here, but we need to note something important about this when we're doing the calculation. Okay, so let's go ahead and do the calculation. So as normal, we would say E cell is E reduction minus E oxidation. So it'll be E gold minus E cobalt. Okay, and we say plus 1.5 minus 0.28, and we get a final value of 1.78. Now we need to note the following. Even though we multiplied the half reactions by various factors to make the electrons cancel, there's one very important point, that we don't multiply the E values by these factors. And this is for a couple of reasons. First of all, that the electrode potential, the standard electrode potential, are intensive quantities. They don't depend on the amount. Okay, remember this is a potential difference. So if I have a line here and a line here, and I have an electron coming here, and it has to jump this gap, okay, to get to this side, right? Whether I have one jumping the gap or whether I have a million jumping the gap, the size of the gap stays the same, and that is the E standard. It's the size of the gap. Okay, so that's why it's essentially an intensive quantity. It doesn't depend on the amount, and we can multiply the number of electrons by however many values. It's not necessary for us to multiply the E values by the number of electrons because of this what I've just explained.